We'll start our class. Today we are going to discuss about the laws of crystallography. As we know that each and every system is always governed by some laws. Like the universe is also governed by few laws. The motion, the climate, the behavior of physical things are all governed by laws. Similarly, crystallography is also governed by few laws. These laws are quite confirmed and can be understood very easily. So let us see what are these laws which governs crystallography. Laws of consistency of interfacial angle. So basically we have three fundamental laws of crystallography in which the first is law of consistency of interfacial angle. This law states that angle between adjacent corresponding faces is interfacial angle of the crystal of a particular substance is always constant in spite of different shapes and sizes and mode of growth of crystal. See what this law actually conveys. This law conveys that the interfacial angle for a particular species or a particular substance will always be constant, irrespective of its shape, size, or the mode of growth of the crystals. So first we have to understand that what is interfacial angle. Interfacial angle is the angle between the two adjacent faces. Here you can see in the figure that the 120-degree angle is between the two interfacial faces which are adjacent to each other. If you'll see or if you'll observe carefully, you can see that the angle between the two adjacent interfacial faces is constant, irrespective to the size of the crystal. You can see that the size of the crystal is increasing or growing, but still the interfacial angle is 120 degree. So this itself explains the law of consistency of interfacial angle. That how the interfacial angle remains constant and does not change after the variations in size, shapes, or the mode of the growth of the crystal. So it is only for a particular substance. Substance changes, the interfacial angle can change. But for a particular substance, the interfacial angle will be constant. Say, for example, cube. Whether you have a small cube or a big cube, the interfacial angle between them will always be 90 degree. So this concept is very easy to understand and it is been conveyed by the law of consistency of interfacial angle. Let us see the second law which governs the crystallography. Law of rational indices. What the rational indices are? Let us see the statement of the law. It states that the intercept made by any crystallographic axis to crystal face will always be represented in whole number. This is little complicated, a little difficult to understand as you have not studied the Miller and Weiss parameter. But for an elementary idea, I would like to tell that just keep observing the figure. You will see that there are three axes in the cube, X, Y, and Z. These axes are intercepting the faces at the point M, L, and N. You can see that the y-axis is intercepting the face H at M. The x-axis is intercepting the face at L, whereas the axis Z intercepting the upper face at N. So The distance between the center and that intercept can be considered as the unit distance. And what the law says? The law says that the distance, okay, the distance or the intercept made by that axis, try to understand the things, the intercept made by that axis on the face will always be represented by a whole number. It will never be represented by fractional number. Why fractional number not cannot be represented? Because it can create different issues in calculations. So it is always represented by the whole number. And if you have a fraction over there, you can nullify it by necessary mathematical process. But you have to always represent this intercept with the help of whole number. And this whole number is nothing but the rational number, because fractional numbers are also called as irrational numbers. So the law of rational indices, indices means the intercept, the representation of the phase with the help of intercept. We will see this in the Miller and Weiss parameter later words. So the law clearly states that there is a necessity of a whole number representation for the intercept of the axis to the face. You cannot use irrational or the fractional number for the representation of the indices. Indices means where the axis intercepts the face, and the representation of that face on the basis of the intercepts are called as indices. We will see this concept in detail when we will discuss Weiss and Millerian indices. For now, just try to mug up the law that it states the intercept made by a crystallographic axis to the crystal face will always be represented in whole number. Law of consistency of symmetry. This law states that all crystals of a substance have the same elements of symmetry, like plane of symmetry, axis of symmetry, and center of symmetry. So this is to be understood very essentially that the law states that for a particular substance, the elements of symmetries are same. As yesterday or the class before, we have studied about the geometric and the crystallographic symmetry. In that, we have seen the axis of symmetry, plane of symmetry, and center of symmetry. The axis of symmetry is the imaginary axis along which, if you rotate the crystal, there should be a repetition of a referred face for minimum twice or more than twice. Plane of symmetry is the plane along which the crystal can be divided into two equal halves. And the center of symmetry is the point at the center of the crystal where on both sides of that center there will be an equal kind of feature. Like if you have a edge on this corner, then exactly on opposite corner there should be a edge at the equidistant. So this law states that for a particular substance, if the elements of symmetries are 23, then it would be same for its all kind of species. So for example, if you have a cube, if you have a small cube, then for cube you will have all total 23 elements of symmetry. But if you have a mega cube, then also you will have the similar number of the elements of symmetry. So for the particular element, the symmetry elements will be same. That is 13, 9, and 1 for a cube. So this is the law of consistency of symmetry. So now I would like to revise what we have studied today. Today we have studied the laws of crystallography, in which the first issue was the law of consistency of interfacial angle. Here you have seen that how for a particular species the interfacial angle is constant irrespective of its shape, size, or the mode of growth. Law of rational indices. The law of rational indices states that the intercept made by any crystallographic axis to the crystal face will always be represented by whole number. It will never be in a irrational form, or we can say that it can never be in a fractional form. You have to convert that fractions, if there are any, to the whole number by a simple mathematical process, which we will see in Miller and Weiss parameters. Then we have seen law of consistency of symmetry, where we have seen that for a particular element or a substance or a species, the number of elements of symmetry are constant. Say for example, for cube, the number of elements are 23 and it will be constant for any kind of cube, because we know that the galena, who is the ore of the lead, also crystallizes in the cube, whereas the pyrite, which is an iron sulfide, also crystallizes in the cube. But both will have similar number of elements of symmetry. So thank you very much. Uh, I'm thankful for your patience listening. Now, if you have any questions, you can just ask.